group meeting,
Hey, we are
please.
live. Do we just
Okay.
want to hop into the quiz? Did anyone have any questions about the prep?
Not really, because I didn't get to enough of it to have questions. I got about halfway through, so we'll see.
Yeah, and me still not confused, but unclear about type 1 error, type 2 error.
Yeah,
But formula is not so, you know, difficult one because we know how to calculate and
mhm.
yeah, alpha is okay, but still don't know which one is. So still, you know, cannot figure out if p value is less than 0.05. So what that mean? Anyway, I don't know.
Yeah. So
Okay.
I'm sure they'll have questions about type 1 and type 2 errors on the quiz, and if they don't, we can talk about them after.
Okay.
This is a 21 question long quiz, so we should
Ooh,
Wow, yeah.
okay,
21
I open
questions?
yeah,
Oh,
probably
yeah.
get started on that.
Yeah. Okay.
okay,
Whew,
I
it's a long
open
one.
and okay, true. Okay, and I'm
Is
ready.
everyone up?
Question
I'm up.
3.
Yeah, I'm getting
Yeah.
in right now.
Okay.
So you go ahead and start reading.
Okay.
So
Which hypothesis involves equality? Equality? I can't remember. The
Oh,
null hypothesis, altern, alternative, alternative,
the
alternative.
the
Anyway,
that would be
or the true hypothesis. Isn't it the null?
right, because it's a statement of this is what is currently accepted, and then we're trying to figure out if it's otherwise.
yeah.
Yeah.
Yeah, so the null.
It's you mean NULL?
Yeah, the first one.
No.
But NULL is an oh yeah, no difference. Oh yeah, good. Thank you. Okay,
Okay. So the
next.
p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed.
I don't know.
Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? Null hypothesis or alternative hypothesis? That would be the null.
Say no
Yep.
because it's at least
That pronunciation no null.
no.
No. Okay, thank you. P-value which is to your
Suppose the null hypothesis is H0. What is that? Mu equals 10. Use the information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test?
I think it's number 3.
Two-tailed.
So to tell me is like equal and I don't know. I
The
don't know this
slash,
one.
the not
Like
equal to.
Yeah, not equal.
yeah, like
So that'd
sad
be
one.
Yeah, the third one.
A.
Uh-huh.
Because it could be either greater than or less than 10.
Yeah.
Not equal
Okay.
to that.
Left. It's second
Left
one.
is less than for the first one.
Uh, less.
So left is less than.
Yeah.
Okay. Left.
Okay.
Left.
So then right-tailed
Sec-
is greater than.
Okay. The me is second one.
Yeah.
Mhm.
Okay. Left, right.
Okay, remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or the fishy. It looks like a fish to me. What relationship would result in failing to reject the null hypothesis?
Failing to reject.
That
The bigger than alpha. Alpha or
So,
If the P is low, reject the null.
So that'd be the second one.
So second one.
Or no,
significant value.
by failing to reject the null hypothesis.
So the first one.
So
Yeah.
so
Because in
second
order
one.
to fail to reject, it has to be greater than. Yes.
It's like trying to read a freaking legal document.
I'm
Yes,
sorry.
the p-value would have to be less than the significant value alpha. So yeah, it'd be the second.
Wait, the p-value has to be less than the significant value?
Oh, no, wait. In order
Less.
to reject it. Never mind. So it'd have to be greater than. Just kidding.
Yeah, because we're
Right,
failing
yeah,
to
so the
reject
first
the null
one.
hypothesis.
Okay,
First
first
one?
one.
We're on
First
question 8, right?
Yes.
Yes.
Yes. So
Okay.
first one is
Yes.
8 is first one.
Yes.
Yes.
Rep 0.05. Oh yeah.
Wait.
No.
Just went over the question. So it's failing to reject. So we do not reject it. So it'd be the significant. We do not quite hit that significant value. So would it be less than? Because
It's
the next one is
alpha.
asking we do reject the null hypothesis.
Because the null hypothesis says it's equal to.
No, should be less than alpha. Alpha?
Because it says if the p-value is small, then you reject. So if the p-value is greater, then you fail to reject.
Yeah.
Okay, yeah. So, okay.
Yeah.
That makes sense. So then the next one would be p-value is small, so lesser than alpha.
Yes.
Yes. So
Okay.
it's the second one.
Sorry, question 8 is first,
The
first
first
one.
one.
Okay,
Question
and then question 9
9
is
is the
second one.
Yes.
Okay. Whew. Okay, information.
Okay, an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. So what would be an appropriate alternative hypothesis? The claim is greater than 1,500. So the third one.
Yes.
Average
Yes. Alternative is greater.
greater than.
Which of the following would be the appropriate null hypothesis? So the average claim amount is equal to 1,500, which is the first one.
Yep.
I'm
The
sorry.
insurance-
Question 10 is third one. Question
Yes.
11 is the first one.
Yes.
Okay.
The insurance company randomly selects n equals 40 claims and calculates the sample mean of X bar equals $1,650. Uses information mentioned next to the questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Sample mean is this
Yeah, I feel like this type of thing, like with the, it's too subjective. Like, how do we know what is going to be a large enough sample size? Like, 40 is a pretty good.
I think for it to be a good sample size, it's got to be over. Was it over 100 or was it over 50?
I think it's over 50.
Yeah, I think over 50 is considered a large size.
So I would say not a good assumption because the sample size is small.
Okay.
Yeah,
So number
it's
2.
gonna be skewed.
Yeah.
Okay,
But
no.
and it doesn't say anywhere that it's normal, right? No, it doesn't. Okay.
Yeah, it doesn't say normal anyway. They're just assuming normal.
Wouldn't it
What
be?
theorem of law justifies your previous question?
Wait, what is law of total probability? Now I'm questioning myself.
I think they just threw that in there as a.
Another one.
It's not a good.
Yeah. Okay. Yeah.
Yeah, law of large numbers is the larger your population, the more.
So
the
that
less
mean
efficient.
is
Central limit theorem is.
I'm thinking central limit theorem.
because
Zero is so
we
close
have
together.
enough sample number.
Because we're basing it off that theorem that if the sample size is large, then it will be normal. But if it's not large, then it won't be normal. So I think it's central limit as well.
Low. First one.
The second one.
The central
Okay.
limit.
Okay.
Which of the following is the test statistic as defined in the lesson? It'd be n, right?
Well, n is the number of observed.
X bar.
It's the Z,
Statistic.
Z.
the second one.
Because x bar is a statistic,
Sample.
n is a
Mean?
statistic, and s is a statistic.
Where z is a test statistic. Yeah, so it's z.
Okay.
Yeah, as defined in this lesson. So I just looked in the textbook and saw that.
Yeah.
Okay.
And then the x is the line over the sample mean, and then the u is the population mean, and then the O thing is the standard deviation and the sample size. Okay. Historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. The test of hypothesis tests with the hypothesis. So the null is $150, and then the alternate hypothesis is it is less than 150. You use the level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes the sample mean of $144. So now question 15, what is the z-score associated with this test? So for this, we need to calculate it out.
Equal 144 minus, it means 144 minus 150. What is the n?
Wait, what's the?
No, it would be 36 minus.
Oh, the standard deviation is 40.
40? 40 and oh no, wait a minute. What is the sample size? Oh, wait a minute.
36. She takes a random sample of 36 sales receipts.
So x mu. Where is the n? In part, like
N would be 36 sales receipts.
where the number come from? 36?
It's in the problem. She takes a simple random sample of 36 sales receipts.
36. So now question 15, right? We are doing that.
Mm-hmm.
Yeah.
Oh, 36. Yeah. Sorry.ひーちゃん、ママの電卓知らない？どこに持ってった？の電卓、あなた使ってたでしょ？電卓を持ってきて。そこ。ママのを勝手に取らないで。そこからの早くちょうだい。はい。静かにして。静かにして。静かにして。はい。静かにして。
Does anyone have an answer?
I'm showing negative 0.15.
That's what I got.
Of course, it's just weird. Normally, if it is a very specific number, they would mention that with the decimal places. Like it'd say just round to 2 decimal points, but this one they are saying round to 3.
So 0. 0.9?
Yay, let's go!
0.899. 0.9. No. So, oh, wait a minute. I'm sorry, what are your answer?
Yeah, we're showing negative 0.15.
Except I think we need to do the other z-score formula, not the one that we were doing.
The one with
So
The standard deviation divided by the square root of the sample size.
So
well, what does that be for a sample mean?
So 144 minus 150. That is a I don't know what.
The numerator, the top number.
Right? Equal minus 6. And the under part is minus 6.667, right? No.
It should be, according to the formula, it should be just 144 minus 150 divided by 40, wouldn't it?
Well, except we do have a sample mean here.
Let me see. Like, it's the mean of the sample, but like what the sample means, it's like taking the mean of a lot of means, isn't it?
Yeah.
So wait a minute. Alpha is okay. Me 150 and
so if you do the square root of the sample
deviation
size
is
one,
40.
it comes out to negative 0.176.
176?
If you do the square root of the sample size, so if you do the other z-score formula.
And x 144 minus 150.
I'm pretty sure here it would just be the regular z-score formula, since it's just like the random sample. It's not like the means being averaged together.
Okay.
So
that's negative 0.15, right?
Yeah,
right. That's what I'm showing.
0.15 minus 0.15?
No, that's the answer we're getting.
Yeah, so negative 0.15. So then the p-value associated with that, which means we need to load up the applet, which I have right here.
Wait, what do you shade in if you're doing the p-value?
Use the let's see.
Where do you shade in the p-value?
I'm thinking it would be the lower end.
I think it would be just the left.
Just the left?
Right, because it'd be like up to that.
So in that case, I got a 0.440.
Well, wait, no, it depends on which one it is what we shade.
Yeah, that's what I'm saying.
So this is, it's less than, so you shade the left.
It's less than. So just the left is the 0.440.
Yes.
So we need to put 0 to like 0.440.
Yes.
Right.
Well, oh, okay.
All right, let's try that.
0.440.
What inference would you make about the null hypothesis for this problem? So the p-value is 0.440, which is
less than, no,
greater
Right.
than the
Uh-huh.
level of significance.
That means fail.
So if it's greater than you fail to reject.
Okay.
Why can't they
Right.
just say that?
Yeah.
Why don't they? Why does they have to say fail to reject?
I don't know. It's really confusing though.
Yeah.
Because I guess
Oh.
you're trying to reject it, so it's, I guess, like, say if you're trying to like take a DVD out to say you failed to eject it. I don't know. It's weird.
It's like reading a freaking legal document.
Yeah. So 0.0 less than 0.05 means reject.
Fail to reject.
Yeah, I need study more.
Yeah, this is a weird chapter.
Okay, so what is the conclusion?
Less than.
So if we fail to reject, then that means
We have
So-
sufficient
Me,
population.
me is the
So
second
me
one.
is
Fail
last.
to reject.
yes. So doesn't
I
that
think
mean that we have sufficient evidence that the true population is 150?
I think it'd be the third one because I don't know we have quite enough to show that yes, it is 150, but we also don't have enough to show that it is less than 150, like they are trying to prove.
Oh,
Which one do
18?
you think
Question.
it is?
Number 3,
So there's
Doesn't say-
insufficient evidence?
because since they're trying to prove that it is less than 150, but we aren't able to prove
Yeah.
that. We also can't necessarily prove that it is truly 150. Like, we don't have enough information for that.
So
But she knows it's
trying to prove is the less than 150.
She knows it's 150. She thinks it's gotten less,
no second one.
and our significance is greater.
So
Would mean
I just
that the
know that
alternate technically should be true.
it is
right?
significant. Significant. I know it's significant.
Oh wait, we failed to.
But
reject the hypothesis.
population means less than.
Failed to
Not
reject it.
less
Is
than.
equal.
Population.
I'd say the second one
I think so.
because we failed to reject the null hypothesis, which means it is equal to 150. And doing that shows that it is 150.
But that's also just a single sampling that we had taken. And so we just, like, we didn't necessarily prove, because rarely with these types of things are we able to truly prove that, yes, this is a fact, especially with just like random sampling. But we also don't have enough evidence to indicate that it isn't.
So the only
Less
thing we
than
can
one.
really do is say that the null hypothesis is not correct.
Correct.
Or sorry, not the null.
Or
What
that
we can
we-
really do is say that the alternate hypothesis is incorrect.
Right.
And the alternate says it's less than 150.
Right, which is why I'm thinking it's number
Evidence
3.
say that the true mean is less than 150. That makes sense, I think.
Well, no,
Yeah, I'd go with the third
move
one.
on.
So third one, second one.
Oh, I don't know.
Yeah, that's my problem. I don't know. Type Ella. So damn.
Here I was feeling good about myself.
So the what's that? State your conclusion in terms of the alternatives. It's a different suitable preparation.
Okay, so in the textbook, it says Since the p-value is less, we reject the null, which is what we did, right? Or no?
Mhm.
Right. No, we were
Yeah.
saying that the null was, in this case, correct.
Because the p-value was greater.
Okay, gotcha. So
Mhm,
then in the
mhm.
textbook, it says, like, based on the like example that I'm reading, it says that there's sufficient evidence to suggest that the true mean body temperature in 2 healthy adults is different. So they're saying it's sufficient when the p-value is when we reject. So this one would be insufficient because we fail to reject.
Mm-hmm.
Right.
It's just a matter of knowing which insufficient
So
it
is it
is.
insufficient evidence that the true
Yeah.
population is 1/5? I think it is the third one because the alternate is trying because she thinks that it's less. We know that it's equal, but she thinks it's gone less. So we have insufficient evidence to say that it is less.
Okay, so the third one makes sense to me
That's
as well.
working through it. That's kind of what it seemed like to me.
Does everyone agree on that?
I'm fine with number 3.
Yeah.
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 Awesome. There
I
are
need
two
to
types of errors that
One
can
of
be
them
made
looks
when performing a hypothesis test. Which one involves rejecting the null hypothesis rejecting the null hypothesis when the null hypothesis is true?
Let's see.
Rejecting is type 1, right?
I
rejecting when it's
think
true.
I'm looking right now.
Yeah.
Type
Whenever
1 is committed when we reject a true null. So yeah, type 1.
Okay.
Wait, what is type 2 again?
Type
2 is the
2.
opposite one. Opposite. What's it?
This is type 2. Type 2 is when you fail to reject when it's false.
Okay, so it's just the opposite, like you said, Mitzi.
Okay, so Richard third decided that instead of using the level of significance of 0.05, he will use 0.01, which of the following will be true.
So that means it's less than 0.05. Type 1.
Would it be the type 1?
No,
Because if it being 0.0, that's a greater probability that the p-value will be greater
the
than,
greater,
which means
yeah.
it will then fail to
So
reject.
it says,
that we would,
Wait a minute. 0.01.
so in the textbook it says if the significance value is very small, the probability of committing a type 2 error will be large.
Oh, okay.
So it will be the second one.
okay.
Yeah, because our p-value could be larger easily, and we would fail to reject when it isn't.
Because we would think it's not significant, so we would reject to fail it, but it turns out it is false, so okay. That makes sense.
Sort of.
Okay, second one.
Hey, the last question. Yay.
Oh,
If
okay.
level of significance equals 0.05, compute the probability of committing a type 1 error.
Well, okay then.
I don't even know.
How do you do that?
How to calculate?
It says the most common value is level of significance is equal to 0.05. This is equal to 1 over 20. There's a 1 in 20 chance that it will be rejected. So what's 1 divided by 20? 20? No, 0.20. What?
Well, wouldn't it be 0.05?
Sounds right to me.
Because that,
Yeah,
5 times 20 is 100, so.
it's 1 over
So
20.
it would just be 0.05.
So if it is at that, so would that be
The probability of committing a type 1 error.
You said
Where did you see that, Savannah?
It's in the textbook under 4.5, type 1 and type 2 errors.
Okay, here it is.
That's the only thing I can see that like would make sense on how to calculate that. Does that make sense what I'm trying to say?
Yeah.
Because a 1 in 20 chance is the probability. Like that's what it says.
Yeah.
1 in 20.
Let's go ahead and just put in the 0.05
5%
and
chance.
see.
Okay, I will submit just because I have to get going to my next group meeting.
I can do the last time. I did. Submit. This one's wrong. See you later.
What class are your next group for?
Communications, we got an 86.
Which ones did we get wrong?
We got 16 wrong and 15
16, 15,
and 12.
12,
16.
16,
And we did our
15,
Z formula.
12. I'm
So
sorry,
12
last one
is
is
not a good assumption
0.05?
since it's small.
Yeah, the last one is 0.05.
Okay.
Okay, and this now 16, 15, 12. 16,
So number 12
12.
was the insurance company selects the N equals 40 claims and calculates the sample mean of X bar equals 1,650. Uses information. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? We said it is not a good assumption since the sample size is small.
Sure.
So
Yeah, that's
we
what
said n equals 40 at large enough sample size?
Well, we used the central limit theorem, so it's got something to do with that because that one was right.
Right?
Yeah, that's
Wait.
true. So maybe it is big enough.
Yeah, I'm guessing it'll just be number 1.
So it is a good assumption because the sample size is large.
It is. So first one, are you?
And that
Yeah, you
one-
guys
yeah, the
talking
first
about
one.
first
Right.
one?
Number 12 would be the
Yeah,
first
12
one.
on the first one.
Number
And
12 would be the
then-
first one, yeah.
It was
Okay.
15 and 16.
Yep.
Okay.
So I guess it is
So-
the other formula then.
Crap, I already got rid of those
Yeah.
numbers.
Yeah.
So that'd be 144 minus 150 divided by 40 divided by 6.
Yeah.
144
So 40 divided by 6.
Uh-huh.
Yeah,
50
I think so.
divided by
Minus 6. Minus 6.
Okay, but I just got negative 0.9.
Negative 0.
Wait.
Yeah.
It's
Negative is
144 minus 150
minus
divided
6.
by
Mhm.
40 divided by the square root of 36.
Yeah,
Right.
that
Yeah.
means 6.
So I got negative 0.25.
0.9.
0.025.
Wait.
40. Huh?
Let me see.
0.025. Negative 0.025.
6.667.
Wow, that makes it stupidly small.
Yeah, I got negative 0.9.
Me too. You got it?
I'm just making sure I did it right.
So the answer is
And
negative 0.9.
minus sample size.
And
How's these four associated with this?
then put the number. P-value.
Thanks.
So the
Well,
P
love you.
value is the shadow is the left side.
Right, it should be the left-hand side.
So that means 0.184.
Yeah, I'm not sure.
So I'm still don't know which one I should shade. No, blue color.
The left, the far left is what you shade.
Okay. So if I do so, my answer is 0.184. I put the 0.9 z-score
Mm-hmm.
and I shade left side.
Yeah, I didn't get the 0.9.
Yeah.
I got negative
The-
0.025, which gives me
So
an
you did
area.
144 minus 150
Yep.
over 40 divided by 6.
I did I actually put in 40 divided by the square root of 6.
No, be the
Oh,
square
wait,
root
Yeah.
I'm
of
sorry. Never mind. I
36.
hit the wrong symbol. I times it.
Yes. So
It would be 40 divided by 6 because it'd be the square root of 36, which is 6.
mm-hmm.
Yeah. Okay, yeah, sorry. I put a wrong thing in there. I times it instead of divided it.
No problem. So
Let's see, what did you
then
get for the p-value there?
I got the negative 0.9 as well.
hang on.
Which
0.9,
leaves you
yeah.
at,
Wait, what?
Is
Oh,
this
doing-
never mind.
z-score.
yeah, doing
So
the z-score
that-
formula gives you the
that
negative
is it.
0.9, which gives you an area of 0.184.
So question 15's answer is minus negative 0.9, right?
That's if we're doing the right formula there.
Yeah.
So we have to. So it's not the answer.
Right, and so now the new p-score is the 0.184.
Mm-hmm. This
Try
is
that.
answer. Okay, 0.1.
And then we got that we were supposed to reject the null hypothesis, correct? So does this new answer still line up with that?
Well, we got it right.
That's what I say. So 17 is right. So did we?
That's what I'm saying. So does our answer for
Because the-
16?
Yeah, because the 0.18 is still greater than the 0.05.
Yeah. Okay.
So that would all still work.
Okay. I'll go ahead and now try and submit this and see if we got those 3 correct this time.
So quick question for number 15, did you type in just negative 0.9 or negative 0.900?
I went ahead and put in the 00 just because it said around 2.
Yeah, that's what I was thinking too. I don't know if it'll count
Okay.
it wrong for that or not.
So that is the 15th answer. Then 16th answer is 0.184.
Yes.
Okay, I got 100%. So it is the 0.9. Probably make sure to include the 00 because I did include that.
And then the 0.184 is right, and then that means we got the other one right too.
So you said we have to put 00 behind the 9, right?
I did. I don't know if they would mark you wrong for that, but it'd be worthwhile to include that just in case.
He did it and it worked. You might as well.
And 0.8. Oh,
Awesome, Frank.
I definitely want to make sure
I gotta go.
okay.
Okay.
Thank you.
I normally won't have a group meeting after this. Someone
Right.
dropped the ball, so we won't be so rushed next week, I promise.
Okay.
Okay.
Sorry about that.
Bye.
And I won't be late
No.
next time. Also, sorry. I'm all
It's
over
all
the
good.
place. So sorry.
Oh, don't you worry
Okay.
about it. Again, I was going to take a little bit of extra time.
Okay. See you guys on
Thanks, y'all.
Monday. Good luck
Bye.
on the test.
You too.
Yeah,
Thanks.
thanks.
Yeah, good luck.